tutorial on function transformations. It is one of the hardest part in advanced function course. So let us begin with the easiest one, the reflection. We begin with the reflection over the x-axis. So for reflection over the x-axis, we look at an original function y equals fx. And the new function y equals negative fx, we say that the new function is actually a reflection over the x-axis from y equals fx. Here we have an example. Let us look at y equals x squared and y equals negative x squared. We will show that the red one, y equals negative x squared, is actually a reflection of y equals x squared over the x-axis. We begin by looking at some of the points. So let's say when x is 1, for the blue function you will have y equals 1 squared, which is 1. For the red function, you will have y equals negative 1 squared, which is negative 1. Some of you may wonder why this is not positive 1, because there is no bracket making this negative sign to have an exponent 2. If I put a bracket here, it means we need to take exponent 2 for this negative sign as well. It becomes negative 1 times negative 1, which is positive 1. However, this negative sign is outside the exponent 2, so we don't have to do anything to it. Therefore, the answer for the red one is negative 1 instead of positive 1. Now, go back to the graph. You have when x is 1, the function value for the blue function is 1. The function value for the red function is negative 1. So we'll see that the second point is actually a mirror reflection of the first one over the x-axis. That is to say, we can treat the x-axis like a mirror. Okay. This point and this point, they're mirror image of each other. Now, we check another point when x is 2. For the blue function, you will have y equals 2 squared, which is 4. For the red function, you will have y equals negative 2 squared, which is negative 4. Okay, go back to the graph. You have when x is 2 here, the blue function will give you a function value of 4. The red function will give you a function value of negative 4 here. So we see that they are of the same distance from the x-axis. Again, these 2 points, they are mirror image of each other over the x-axis. So we say that y equals negative x squared is actually a reflection of y equals x squared over the x-axis. In general, we'll have y equals negative fx is a reflection of the original function y equals fx over the x-axis. Okay? There are some other examples apart from the one that I have given here. Let's say if we have the original function to be y equals x minus 2 squared. For the function y equals negative x minus 2 squared, we say that it is a reflection of the original one over the x-axis, because you can see that this part of both functions are the same, but they just differ by this negative sign. Okay? Another example is y equals x squared minus 4. Okay? For the function y equals 4 minus x, we found that it is also a reflection of the original one, x squared minus 4 over the x-axis, because we can rewrite it in this form. Now you can see that, again, this part are the same, and both functions, they just differ by a negative sign. Okay, so this negative sign affecting only the value of y, we say that this kind of new function is a reflection of the original one over the x-axis.